Okay, here's our video today, how fungus made life possible. It's actually how fungus made life on land possible. Fungus among us. Let's change that. Fungus on land. Well, life on land. Just write it over here. Life on land. Without the fungus, we wouldn't have had plants on land, and without the plants on the land, there would be no animals. So simple as that. Without the fungus, life would not have been possible on land. So let's get a clean page here. By the way, you're looking at this nice edible orange spongy mushrooms. And don't eat them if you see them, by the way. Don't eat any mushrooms unless you're an expert. You gotta be very careful when you're eating mushrooms. Some mushrooms that look safe or could be safe could actually be poisonous, so be careful. All right, let's get a clean page. All right, maybe we'll use red. So life began in the water. We know life began in the water about 3.7 billion years ago. So let's write that down. Life began, and this is microscopic life. Life began in the water. So we know it began in the water. And we'll say circa 3.7 billion years ago. And we're getting more information that perhaps it's even earlier than that. And remember, the Earth is 4.6 billion years old, so roughly a billion years without life on this planet. And again, I said microbes. We owe a lot to microbes, then and now. And so a billion years after Earth was formed, life began. And life on land, so we should have, this is in the water. So life on land would come, of course, if you're looking at these terms, it seems pretty close, but in our mind, it is a long time. But 3.2 billion years ago, life on land began. And of course, these would have been microscopic bacteria. So the first life on land would have been bacteria. And the bacteria did not need the fungus. So we should clarify this. Life on land through plants and animals would not have been possible without the fungus. So bacteria and protists 3.2 billion years ago would colonize the land. All right. And we'll put a little line here. But for non-microscopic animals, we're looking at 480 million years ago. And these would have been the plants. And we're talking about non-vascular plants, basically without stems. And you know the non-vascular plants. There's like moss, hornworts, liverworts, non-vascular. But if we're looking at vascular, all right, vascular with stems, basically, xylem and so forth, vascular plants would have been about 425 million years ago. And we'll get to, can we fit the ago? Probably not. Million years ago. I'll put it on the bottom. Why not? So again, life began in water 3.7 billion years ago. And on land, we're talking 3.2 billion years ago. But the plants that came on land, non-vascular, like moss, 480 million years ago, and vascular, 425 million years ago. And these vascular and non-vascular, they needed fungus. They needed fungus to help them colonize the land. And I think it's an important note that animals, even though they were later, they came on land later, about 360 million years ago. Animals would form on land. They do appear before plants in water, though. Animals in the water, besides bacteria, they can go back 600 to 650 million years ago. So animals beat plants in water first, but on land, it's the plants first. And the fungus, they would colonize the land about 1 billion years ago. So the fungus were on the land before the plants. And now the fungus, this interesting thing about the fungus is that with the plants, they're going to form this symbiotic relationship. So we'll talk about that. And here's a good picture of that. So the fungus, we know that they form, even today, back in the past and even today, they form symbiotic relationships with plants, both non-vascular, without stems and roots and so forth, and vascular. And what they do in this symbiotic relationship is that and you can see right here, let's get my pen ready, use our red, all this fungus, right, this is hyphae, all these stems, they're connecting to every tree in the forest, right? Everywhere. You can just see it. And this is under our feet. We don't even see this. This is what a lot of scientists call the wood wide web. The wood wide web. Getting a little angle here, right? The wood wide web. It's a connection. Everywhere on this planet, fungus is connecting to trees and plants everywhere. And what they do is they help the tree, the plant, with nutrients, right? They'll give them the nutrients they need, the water they need. They'll help them increase that nutrient uptake. And in return, the trees will give them the sugar. So the fungus give the nutrients that, especially, and well, let's write it over here, that they need. The trees need phosphorus, and they'll help with that. They need phosphorus. They need nitrogen broken down. We all need nitrogen, by the way. And in return, in all this symbiotic relationship, in return, they get the sugar, the glucose. That's what they're looking for. The fungus is looking for. So there's this symbiotic relationship. So let me clear that out, clear out the writings. So this network, it is a network. It allows access all over the planet. And I'll write this down here, get my pen ready. Mycorrhizae. I'll spell it for you. This is the fungus network, the fungus. This mycorrhizal network. And they have, like I said before, they have these little arms, you can call them, little structures like roots. You can see them in the picture. Hyphae. And the hyphae extend out and they bury themselves in the roots of the trees. And they've been doing this early on in the evolution of plants on land. It's this for that kind of a structure going on beneath our feet, beneath our soil. And they actually scientists have a name for it, the CMN network. Not on television, though. It's called the Common Mycorrhizae Network. Mycorrhizae. The Common Mycorrhizae Network, CMN. And of course, there's the whole theory on this is called the endosymbiotic theory. I'll write that down, endosymbiotic theory. And of course, there is symbiotic relationships with many animals and plants throughout the earth today and in the past. So the question now is like, how did this even happen? Now, that's a good question, right? We don't have any fossil evidence for this, but we know that they would not have been able, when plants were leaving the oceans, they had a lot of problems, of course, especially non-vascular plants. They would have had problems with structure, and they had to develop these adaptations and for water intake, and of course, that's where the fungus came in. But the first plants, though, would have been non-vascular anyway, but they relied on the fungus also. Remember, you're leaving an environment where you're getting your nutrients and water to dry land in many different conditions. Here's a better picture of the mycorrhizal network, going from roots to roots in every tree and plant all over the world. And there has been evidence that if a tree is damaged or in disease or needs nutrients and it's not getting the nutrients, the mycorrhizal network will borrow nutrients from other trees all over the forest. It's an amazing network that is still being studied. So here we can see the common ancestor of the non-vascular plants. Make sure I have my pen ready. Let's change it up. We'll use green. So right here, this would have been the common ancestor, whatever it was. And then we have the non-vascular going this way and the vascular coming this way. And so the fungus would have had a symbiotic relationship with that common ancestor. And eventually then others would form in the evolutionary tree. So again, those mosses and liverworts and hornworts, they would have had a common ancestor that would have, again, given the fungus the sugar, the glucose it needed in exchange for other nutrients like phosphorus and water and nitrogen. All right, so that's our video today. So again, we owe fungus our life in a way because plants needed to get on land. They had a lot of stress getting on the land, getting those nutrients, getting that water, and fungus made that possible. Life on land through this symbiotic relationship. And of course, animals would follow because then they could eat plants, and then you have a domino effect. So that's our video today.